Okay, so today 3.2, solve and graph equations and inequalities. Yesterday on Tuesday we solved using the additive inverse. Today we're going to solve using the multiplicative inverse. So what is the multiplicative inverse, you ask? The multiplicative inverse is the product, when the product of a number and its multiplicative inverse is 1. So if I give you a number and we take the multiplicative inverse and we multiply those two numbers together, we're going to get 1. This is also called the reciprocal. Same thing as reciprocal. How many of you have heard of the reciprocal before? Okay. So multiplicative inverse is the same as the reciprocal. Additive inverse was the same as what? What did we call it? Opposite. Okay, how do we find the reciprocal? We just flip the number. Okay, so let's think about this for a second. If I give you a number like 2/3, what would be the reciprocal of that? Good, 3/2. We just flip it. And then let's think about it. 2/3 times 3/2. When I multiply those, what do I get? 2 times 3 gives me 6. 3 times 2 gives me 6. And 6/6 reduces to 1. So these guys are multiplicative inverses. What if I have a number like +4? What's the reciprocal of that? No, if we change the sign, that's the opposite. +4 is the same as 4/1. So what would be the reciprocal of that? 1/4. So you have to remember that whole numbers have a 1 underneath them. What if I give you a number like 1/3? What would be the reciprocal of that? 3/1, which is the same as 3, right? So all of those are multiplicative inverses. Okay, guys, so when do we use this? We use this to solve equations. So you remember how we had the addition and subtraction property of equality? We also have multiplication and division properties of equality, and they tell us that you can multiply or divide both sides of an equation by the same number and the statement will still be true. So it's just like the addition and subtraction properties of equality. Because an equation or inequality is like a scale, whatever you do to one side, you must do to the other. Want to, you can. So let's think about it. If I have something like 6 = 6, that's a true statement, right? Okay, now I can multiply both sides of this equation by 2, and what would I get? 12 = 12. Is that still true? Yeah. What if I only multiplied one side of the equation by 2? Then I would get 12 = 6. Is that true? No. That's why we have to do the same thing to both sides. We have to keep it balanced. Make sense? Okay, so now we're going to do a couple of examples. So example number 1, 2x = 14, and we want to solve for x here. Okay, so 2x = 14. We want to get x by itself. Remember, that's always our goal. So what is 2 and x, or what's being done to them? Are they being added? Are they being subtracted, multiplied, or divided? Multiplied, right? And whenever we were solving for x, we always do the opposite. So what am I going to be doing to get rid of that 2? I want to divide both sides by 2. Why do we do that? Let's think about it. What is 2 divided by 2? 1. So what are we left with? 1x equals 14 divided by 2 is 7. Let's check it. So we check it by plugging 7 in for x, so we would get 2 times 7, and we want that to equal 14. 2 times 7 gives me 14. 14 equals 14. Is that a true statement? Yep, so we got the correct answer. So we're doing the exact same thing we did on Tuesday, except now we're multiplying and dividing. Example 2. 10 equals negative 5y. Alright, in this case, the variable is on the right-hand side of the equation. Is that okay? Yeah. So we have negative 5y. What operation is that? It's still multiplication. So to get rid of it, I'm going to divide both sides by negative 5. I am not going to add negative 5 because this is the same as negative 5 times y. So to get rid of that negative 5, I need to divide. Because what's negative 5 divided by negative 5? 1. So what are we left with on that right-hand side? Just a y. 10 divided by negative 5 gives me negative 2. So my answer, negative 2 equals y. Let's check it. So we want it to equal 10. We have negative 5 times negative 2. We want our equation to equal 10, and negative 5 times negative 2 equals positive 10. So is that a true statement? Yep. So we got the correct answer. Alright, example number 3. 4k is less than negative 32. Alright, even though we have an inequality, we still do everything the exact same way. So I have 4k, which is the same as 4 times k. So what am I going to do to get rid of that 4? Divide both sides by 4. 4 divided by 4 gives me what? 1. So on the left-hand side, I'm just left with a k. Less than negative 32 divided by positive 4? Negative 8. So my answer is y less than negative 8. Or k less than negative 8. Thank you. Let's check it. Alright, how do we check this? We're only looking for k's that are less than negative 8. So can k equal negative 8? No. So what's a good k to pick to check? Negative 7. No, is negative 7 less than negative 8?
Yeah.
Oh, no.
No. It's bigger. So what would be a good one to check?
9.
Negative 9. So let's do 4 times negative 9. We want it to be less than negative 32. What's positive 4 times negative 9? Negative 36. Less than negative 32. Is that a true statement? Yes, it is. So we got the correct answer. So let's try example 4. This time we have n divided by negative 9 equals positive 5. So this is a little bit different. First, because when you fall, it's my fault. And then what's your question? Guess what? There's an example like that. I think there's an example like that. Oh yeah. There's 12. There isn't an example like that, but I'll tell you. Okay, that's not what we're doing right now. Okay. So let's check it. Check, check, check. How do we check it? We plug it back in. So we get negative 45 divided by negative 9, and we want that to equal positive 5. We're not sure yet. What's negative 45 divided by negative 9? Positive 5. Positive 5 equals positive 5. Is that true?
Yes.
Yep, so we got the right answer. Example number 5, guys. F divided by 5 is greater than or equal to positive 5. Okay, so F divided by 5, we are dividing. So what is the opposite of division? Multiplication. So I'm going to multiply both sides by 5. 5 divided by 5, what does that give me?
1.
1, so they cancel, right? So we're left with F greater than or equal to 5 times 5, 25. So we're looking for all F's that are greater than or equal to 25. So let's check it. Time out, Hunter. Okay, so how can we check this? Let's think about it. Can F equal 25? Yeah, because we're greater than or equal to, so let's plug in 25 for F. So we have 25 divided by 5, greater than or equal to positive 5. What's 25 divided by 5, guys? 5. Greater than or equal to 5. Is that true? Yep. So we have the right answer. All right, example 6. Uh-oh, this time we have a negative. Negative x over 6 equals positive 3. Okay. If I have negative x over 6, the negative is on the outside, does it matter where my negative goes, the top or the bottom?
No.
It does not matter. So if I'm dividing and I have a negative 6, what am I going to multiply by? Negative 6. Because negative 6 divided by negative 6 gives me a positive 1. So what am I left with on the left-hand side? 1, a positive x, right? Equals, oops, positive 3 times negative 6? Negative 18. Let's check it. We have negative on the outside. X is negative 18 divided by 6, and we want that to equal positive 3. Okay, I'm going to keep that negative on the outside. Negative 18 divided by positive 6, what does that give me? Negative 3 equals positive 3. We're still not sure. But I have minus and negative, so what happens? Both become positive. So I have positive 3 equals positive 3. Is that true? Yes, it is. So we got the correct answer. Little tricky, huh? Example 7. This one is a tricky one.